Welcome to today's Explainer. There is a massive geological mystery hiding right in plain sight. Have you ever stood on a beach, tasted the salt spray in the air, watched a huge rushing river empty directly into those crashing waves, and just stopped to think about the mechanics of what you're actually witnessing? We live on a planet where our vast, endless oceans are filled with heavy salt water, while the millions of miles of rivers that constantly feed into them run fresh. Well, today, we are going to unpack exactly how that works. This right here is the overarching question we're answering today. Billions of gallons of fresh water dump into the ocean every single day. By all common logic, the ocean should be diluted and fresh, right? Or, conversely, if the ocean is a giant bowl of salt water, shouldn't the rivers delivering that water be salty too? To understand why they aren't, we have to completely change how we think about water. We need to shift our view from just seeing a liquid to seeing a highly active chemical transportation system. So, here's our roadmap for today. We'll start with the Great Salt Paradox, see how it actually starts in the sky, ride the mineral highways of our rivers, dive into the ocean's evaporation trap, and wrap up with millions of years of accumulation. All right, part one, the Great Salt Paradox, the big picture. Taking in this whole interconnected cycle of rain, rivers, and the sea, it becomes pretty clear that the ocean's saltiness doesn't just magically appear out of nowhere. It ultimately comes from dissolved minerals, or salts, that flow into it and gradually build up over a very long time. The ocean isn't just a static body of water. It's the final destination for an absolutely immense geological process. Moving on to part two. It starts in the sky, the atmospheric catalyst. Now, what's really wild about this cycle is that the journey to a salty ocean actually begins way up high in the atmosphere. It's not just pure, sterile water falling from the clouds. Rainwater interacts with volcanic gases billowing up, as well as naturally occurring carbon dioxide in the air. It's literally a brew of atmospheric chemistry taking shape right before our eyes. So the absolutely crucial point here is this invisible chemical chain reaction. Step 1, those volcanic gases and CO2 mix intimately with the falling rain. Step 2, this mixture causes the rainwater to drop in pH, becoming mildly acidic. It's weak, you wouldn't even notice it on your skin, but give it enough time and it's powerful enough to dissolve a mountain. Which leads us to step 3. When this acidic rain hits solid terrain, it physically and chemically begins to erode the rocks, releasing the minerals locked inside. Which brings us to part 3. Rivers, the mineral highways. Seeing the immediate aftermath of that mildly acidic rain is fascinating. Those eroded rocks don't just disappear into thin air. Instead, the microscopic minerals from the rocks become hitchhikers. They dissolve directly into the flowing river water, completely invisible to the naked eye. And this, right here, is exactly why rivers aren't salty to the taste. Rivers act as incredibly efficient mineral highways. They have clear outlets, so they are constantly transporting these dissolved salts down from the land. Because the water is continuously flowing from higher elevations down towards the sea, the minerals never have a single chance to stop, settle, or accumulate in the riverbed. The river is just the delivery vehicle, constantly flushing fresh rainwater through the system and carrying its mineral cargo away. Okay, part 4. The ocean's evaporation trap. This perfectly illustrates the fundamental contrast between these two bodies of water. On one side, we have rivers, the highway, flowing water with clear outlets, constantly transporting minerals away. On the other side, we have the ocean, the sink. The ocean is effectively a giant basin of trapped water with absolutely zero outlets. Once water and minerals enter the ocean, there is nowhere else to flow. Think about what happens when the sun heats the surface of the ocean. It causes the pure, fresh water to evaporate back up into the sky to form new clouds. But here's the catch. The heavy, dissolved salt minerals? They can't evaporate. The fresh water escapes back into the atmosphere, but the salt is left permanently behind in that ocean sink. And just to add another fascinating layer to this whole system, deep beneath the waves, glowing seafloor vents are actively pumping even more minerals directly from the Earth's crust into the seawater. So the ocean is constantly receiving minerals from above via rivers and from below via vents, while only ever allowing pure fresh water to leave. Finally, let's hit part 5. Millions of years of accumulation. Let's formally define what we're looking at here: accumulation. It's the gradual gathering of dissolved minerals in a sink with no outlet over an immense time scale. You see, one drop of mildly acidic rain or even a single rushing river over a single day doesn't instantly create a salty sea.
The amount of salt a river dumps into the ocean on any given Tuesday is microscopically small. The real secret is continuous, relentless accumulation. While regional changes happen over millions of years, the overall salinity of our oceans is the result of this cycle churning continuously for billions of years, literally ever since the first oceans formed.
The sheer vastness of the ocean means that it takes an almost unfathomable amount of time for these tiny mineral deposits to build up to the point where the entire global ocean tastes like salt. It's a true game of patience.
As this quote sums up beautifully, over millions of years, dissolved minerals accumulate, making the ocean salty. It's a slow, completely invisible process, rainwater turning mildly acidic, eroding rock, flowing down highways of fresh water, and becoming trapped in a giant sink. It completely changes the chemistry of our planet. It's just an absolute testament to the incredible power of deep time. So, as we wrap up today's explainer, I really want to leave you to ponder this massive scale of cause and effect. Think about the combined power of water and time. If immense periods of invisible, microscopic erosion can turn the unfathomably large oceans completely salty, what else is the slow, continuous cycle of water quietly reshaping right under our feet today? Keep looking closer at the natural systems moving all around us. Thank you so much for joining me. Keep your curiosity sharp, and I will see you in